Hi there, Charlie.
Hi, Martha.
How are you?
Very well. I have a very quick question.
Yeah.
The moon is a waxing crescent, and then it turns into a waxing gibbous.
Yeah.
When does that change take place?
Please. At the half quarter,
Half
at,
quarter.
at the
Okay,
quarter moon, or the
gotcha.
half moon. Yeah.
Thank you.
I'm pretending that I'm in Italy as usual with my moon in the background, but I'm actually in Rhode Island
Good gracious.
as I'm visiting my brother for a couple of days, and then he's headed off to Maine to spend Thanksgiving with his stepson and family, and I'm going to visit my nieces,
Oh
and
my goodness.
I'll be with three of them.
Whereabouts in Rhode Island?
Portsmouth,
Okay.
it's a very nice place, actually.
Yeah.
We're my our daughter Megan is coming up. We're not going to Chicago or anything. And then the three of us are going up to Syracuse, which has become a new
Yeah,
central
yeah.
central point for Lemley's John's
Well,
family.
this way I came a few days early because I knew that my brother would go up to Maine.
You got a
Um,
chance to see him, yeah.
and but I got a chance to see him, and then I'm going to my nieces are my late sister's daughters, and they
We,
get together. Um,
we from these large Irish family,
yeah,
American
yeah,
family,
yeah, 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 yeah. But
pick
it'll
a
be it.
house you want to go to. Yeah, that's all you
Yeah,
do.
but it's fun, and actually the niece and my brother, she lives in Massachusetts, he lives in Rhode Island, but Rhode Island is a very small state, so it's only about 30 miles. Anyway, I'm glad to see a few people here. I wasn't sure when we picked this date, we weren't really sure about the date, but we did it anyway.
We're getting there. It looks like nine, including
Yeah, yeah,
you.
yeah, yeah. No, we're as far as I'm concerned, we're there. But I'm not serving turkey.
Damn.
So we'll wait one more minute and then we'll start. So okay, well we've got a good crew, so why don't we get started? So so the first question I'm going to ask is, has anybody read about the idea that there's a comet out there that is evidence of alien technology? Yeah, okay, Alan has, I see. It has been discussed. Um, but that really wasn't why I chose this topic. I thought it's just the idea of comets is an interesting topic, but we'll come back to the fact that we think we understand what a comet is, and comets have been observed, as we'll discuss, for 10,000 years. Um, and what they are is literally dirty snowballs. But they've also been had some ill repute as harbingers of doom, which we'll also talk about. And most recently, a comet, actually a couple of comets, have been suggested to be possibly evidence of alien technology. So I pick a couple of pictures, of photos, an illustration, an actual photo of a comet in the sky. This is actually Halley's comet. And this is a close-up of Halley's comet taken by the Giotto spacecraft. So let's talk about comets, if I can figure out how to run this computer. Okay, so let's also talk about what's up in December, just because we do that at the beginning of every session. The moon was new on the 19th, and so it's now at about first quarter. The next full moon is on December 4th. next week. And it's called the cold moon. I guess we can understand why that is. And it's a supermoon, meaning that in the moon's elliptical orbit around the sun, it is at its closest point or near its closest point to the Earth. So it's at perigee. So it's a little closer to us than average. And so it will appear bigger and brighter in the sky. And then, of course, the other thing that happens in December is on December 21st, the sun is at noontime at its lowest point, lowest altitude above the horizon, and that is the point where the sun will start actually moving further north. So if you want to think of it, we're in the worst time of the year right now in terms of darkness, and after December 1st, spring will start coming. Just keep thinking about that as the next month goes by, especially December, where they're saying it's going to be very cold. As far as the planets, Mercury actually rises early in the morning before sunrise, and its greatest point furthest away from the sun will be on December 7th, but you got to get up early in the morning. Venus shines brightly towards the west now at sunset, but it sets early, and then it will come around and you can see it in the east before sunrise. Mars is really not very visible right at the moment. It's almost in lined up with the sun, so it's really hard to see. Saturn and Jupiter are both visible during most of the night. So if it's clear some night in the next weeks, go outside, try to find Orion, and look for Saturn and Jupiter in the sky. Okay, so another thing that is up in December is there a couple of meteor showers. So I just also thought it was useful to remind ourselves of the terminology that meteors are space rocks. They usually come from comets. They are debris, and they occur when the Earth moves through the tail of the debris of a comet that has probably long passed. And so remember that because we'll be talking about comets and tails. The comets themselves, the head of the comet, the nucleus, is very small. It's made of rock, ice, and gas. But as it comes close to the sun, its outer layers evaporate. And while the comet nucleus, this rocky, dirty snowball, might be only a few miles across, debris tail can extend over hundreds of millions of miles. And so if the Earth goes through one of those, you can get a piece. We also see space rocks that come off of asteroids, but we can, as the Earth goes through these comet tails in particular, there will be little bits of rock, the leftover of from the comet itself in the debris tail, and those can enter the Earth's atmosphere. And when they do, we see a meteor shower. So there are two of them that occur in December. The Geminid meteor shower, which means it's in the direction of the constellation Gemini, which I suggest you find by Googling some web or app, which will tell you where to look at a particular time of night. Timeanddate.com is good for that. You can also see the Ursid meteor shower, which is in the constellation of the Ursa Major, Ursa Minor, in that direction towards the north. Both of them are pretty good favorable to watch during this period because the moon is relatively close to new during both periods. That the new moon will be in between them. And so if you go look for the Geminids in a dark location in the week of December 13, 14, after 8 o'clock in the evening, you might see some shooting stars. If you look in a dark location after midnight later on in December, you might see the Ursids. Okay, so back to comets. This is just a nice little picture that I think shows that you can be sitting out, have a reasonable, take a picture, or if you've got some good camera on your iPhone or whatever, you might even be able to actually see a comet with the naked eye. And so this is the picture of a comet that appeared last year. So, what are comets? So, here's a comet. Again, I'm trying to pick something as it might appear to the naked eye. Here's the comet right over here. You see it has a bluish nucleus, and then you can see maybe, I hope you can see this tail coming out from it. Um, this is a view of a comet called Comet 2025, which means it was discovered in 2025, R2 Swan, and it was taken in September. I'll show you another picture of that in a minute. And this is a picture of the close-up of the core of a comet, which was imaged by the Rosetta spacecraft about 10 years ago. And so you see, this is the nucleus of the comet. So that's buried down in this little blue blob. The blue blob is also surrounded by a coma or halo of gas and dust. And the nucleus is typically about 10 miles across. Some of them are smaller, some are bigger. Some of them have this fuzzy core around the outside. But the tail, as you can see here, extends very far back. I can trace it in this image kind of this far back. That's a big distance in numbers of miles. So why are we interested in studying comets? Well, again, we have a comet nucleus with a coma, and maybe it has some tails. And the tails may not, a comet can have more than one tail because comets aren't spherical bodies. Sometimes they look like this peanut thing. And so they can end up having multiple tails, and some of the tails might be dominated by dust. Some of the tails might be dominated more by gas with less dust. And so they can be quite complicated. We think that comets originate, or many comets at least, originated from very, very far out in the solar system in what we call the Oort cloud, which I'll show you, try to define better in a moment. The early, and then they are on very, very elongated orbits, which occasionally or once in a lifetime bring them in close to the sun. We only see them when they're in close to the sun, but they might spend billions of years or millions, hundreds of millions of years most far away from the sun in the outer solar system. So if we can study them and learn something about them, we can learn what the solar system was like in those early days. We also, by studying the properties of the gas and the dust, which we can do by various means with telescopes, as I'll show in a little while, we can learn something about what that primordial material out of which the sun and the planets was formed. Because what we're seeing is the relics of that coming into the inner part of the solar system for the first time. What we also learn is that these comets that come from way out in the solar system actually contain complex organic molecules. And we believe that over the course of the history of the solar system, which goes back 4.5 billion years, the Earth has many, many times been struck by comets, has gotten material added to the Earth that are these volatiles and complex organic molecules. And so some of them we think came from this early, this primordial material that comets represent. Okay, so let's also understand a little bit about the fact that comets are, the planets and comets and other strange bodies in the solar system travel on orbits around the sun. Remember, the orbits are elliptical. The planets follow elliptical orbits that are almost all in the same plane. Okay, what we call the plane of the ecliptic. And they also travel in the same direction in their orbit around the sun. Like they were on a racetrack and they're all going around on the track and in the same direction. There are also these objects which we call dwarf planets. Pluto is the most famous one because it was demoted from being a planet to being a dwarf planet because it's much smaller and also doesn't clear out its orbit. They follow orbits that are also in the same direction, so going around the racetrack in the same direction, but they aren't all lined up in the plane. Some of them are inclined, some of them are highly elliptical, whereas the Earth's orbit is almost circular, though you can't really see that in this little diagram. What we're going to see is that some comets have really weird orbits, which makes them different. Okay, so where do comets originate in the solar system? So here we have the solar system, here we have the sun and the Earth and the planets that we know and love. And outside of that, but still in that disk that we call the ecliptic, there seems to be a location where you find a lot of comets outside of the orbit of Neptune, even outside the orbit of Pluto. Though that is called the Kuiper Belt after Gerard Kuiper, who noticed this some 60 years ago. And most of the comets that we see that are relatively short period, in other words, that have orbital periods around the sun of less than 200 years, like Halley's comet, which we'll talk about again, and which you might remember having seen in 1986, has an orbital period of every 76 years. It comes back, it repeats. It's a highly elliptical orbit, but it repeats. It probably comes, at least now in its history, and we'll talk about that more in a minute, from the Kuiper Belt. But if there are other comets that exist much further out, so this diagram also underemphasizes or does not really show you the distances to scale. The Oort cloud is much further out, and the Kuiper Belt is much further out than the planets, as you see here. The long period comets, which might have periods from thousands to millions of years, are believed to come from this Oort cloud, and it's really spherical. The Kuiper Belt is kind of a disk, roughly the same disk as the orbits of the planets around the sun. It was, in fact, only in the last decade that a spacecraft called New Horizons, which some of my colleagues here at Cornell were involved in, that showed that the Kuiper Belt actually goes further out than previously thought. But the important thing, and may even overlap with the Oort cloud, but the important thing is that it's disk-like, the same way that planets are. What we think these comets that come from the Oort cloud are really composed of primitive material. They might not have ever come close to the sun before, or maybe they come to the sun, close to the sun millions and millions of years ago. They are composed of primitive material, and so they tell us something about what the early solar system was like. So here are just, again, a couple of examples of two comets that happened to appear in the same part of the sky at the same time. This was taken on the same night, two particular comets, and I outline them here so that you can see the head of the comet, the compact bright nucleus, and the greenish coma, which is expelled gas. And then you can see an ion tail extending out from both of them. I'm going to take away the little circle there so you can see, oops. Yeah, that happens every now and then. I get too anxious. You can see the tail going way, way out. So we think, in fact, that this comet comes from the Oort cloud. And we'll talk about this a little later, but that's because we're actually able to figure out what kind of gases and molecules are in that coma and tail. And it has a very low amount of carbon and a low dust to gas ratio, which is somewhat unlike most comets, especially Kuiper Belt comets. This one, on the other hand, has an orbital period of about 770 years. And it just happened that this year it passed into the inner solar system, and is going to go back out and won't come back for another 770 years. Okay, so again, what's interesting about comets is that they're visitors from the outer solar system. We think that they form when ice and dust left over from the formation of the sun clumped together. You know, there were all these lumps of things. The early solar nebula wasn't not all these bodies had formed. Instead, there were little bits of rock and dust that got together. Sometimes they collided with each other and formed something bigger. Um, Comets, as I said, the planets orbit in roughly circular. They're slightly elliptical orbits. Comets revolve in highly elliptical orbits. So here is this little diagram that shows you an elliptical orbit. Comets revolve in highly elliptical orbits, which means they travel far away from the sun part of the time and close to the sun at other times. They can also travel on what we call parabolic or hyperbolic orbits, where they might not come back for a really, 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 really long time. So you don't think of them as being closed like this. Another thing that happens is some of the comets that come from the Oort cloud comets actually are going in the wrong direction. So they're on the they may not be on the racetrack. They might be inclined with respect to it, but in any event, they're traveling the wrong way that the other horses are traveling. And they can be out of the plane. They don't have to be in the plane the same way that the planets and even the dwarf planet in the plane. So here's another comet, which we could actually see from Ithaca at one point about a year ago. It's got this name which has to do with the person who discovered it or the experiment, the observing program that discovered it. That's where the names come from. If you discover a comet, the comet can be named after you, but nowadays many comets are discovered by surveys using robotic telescopes that scan the sky all the time. So the next question that you might ask is, why do comets have tails? So a comet is a dirty snowball, and they're made of frozen gas and dust. But of course, as the comet comes in close to the sun and it's traveling on an elliptical orbit, so it's really far away out here, and then it comes into the sun, and then it travels past again. The outer layers of it get heated up by the sunlight. And when that happens, you get particles, the frozen gas and gets evaporated and the dust breaks off. And you can end up stripping away material from the core and it forms a tail. But because the sun is always shining in this direction, those tails will have a tendency to always point away from the sun due to the radiation pressure of sunlight. Sunlight itself actually heats up material and pushes the material in the tails away. Sometimes you can get multiple tails again because some of the tails are made of dust, some of the tails are made of gas, and they don't necessarily line up. David has a question. Please, David.
Okay, yeah, I have a couple questions. So, as the comet approaches the sun, some of the stuff melts and it becomes the tail, or it vaporizes. So, my question is, will a comet eventually run out of material? You know,
Yeah,
a million
it will.
years ago? Okay.
Right. Well, it turns out that the amount of material and this is what boggles my mind, the amount of material that actually evaporates off is very small, and yet it can make a tail that is visible and extends hundreds of millions of miles. It's really
So
amazing. It doesn't
if
take
one,
much.
okay, if one was standing on, say, Neptune, and the same comet came by, would its tail be as long as it appears from the Earth, which is closer to the sun? Or would by then a lot of this stuff be,
Well,
dispersed?
if Neptune was observing at the same time we were observing, the tail would be the same length.
Okay. Oh,
Okay,
but
and remember, and this is where you get the meteor showers. These tails, the comet kind of keeps on going, and the tail is left behind, like a contrail,
got it.
right? You see a contrail behind a jet sometimes because of the physics of the Earth's atmosphere. You can get a little bit of gas coming out from the jet or disturbed in the cloud by the jet, and you form a trail. The jet keeps going on because it's like a bullet. The tail is still there. And so once a year, we go through an old comet tail and we get the Geminid meteor shower. But the amount of material in that meteor shower, in those meteors, it's like little grains of sand relative to the solid body, which was the comet. It doesn't take much to make a tail. Did you have another question? I think you're muted if you're asking another question.
Nope, I'm okay. Thanks very
Okay.
much.
Okay. So the tail normally points away from the sun because of what's actually happening. Sometimes, as I said, you can get multiple tails because comet nuclei are sometimes multiple themselves. They're like snowballs stuck together. So here's a comet, and I showed this diagram in an LLH presentation a year ago. There was a comet that was visible in the sky for a period of time in October of 2024, and maybe some of you got to see it, although my recollection is the weather wasn't very good. There's a surprise. But here's a picture of the comet, and I wanted to show the difference. So. Um, this is basically a photograph that somebody took of the comet in the sky. But again, you can see the comet nucleus and coma, and then you can see this amazing tail. And this is a close-up made with a 12-inch astrograph telescope by couple of amateur astronomers and an astronomer, and it shows you the different tails that you can get and all of the structure in them. And by understanding, by trying to figure out the composition of the structure by looking at the light from the different structures in great detail and watching what happens over time. Astronomers can try to figure out what the comets are made of. We talk about gases, what gases are in it. We also talk about dust. When dust, we're talking about tiny grains, even smaller than a grain of sand, and different kinds of materials, silicates, stuff that has iron or nickel. They will show different kinds of light also that we can analyze. Here's another one, which was actually visible in Ithaca that was called Comet Neowise in 2020. Again, here's a nice shot that somebody took over Stonehenge. And here is a more professional close-up of the comet. Again, I want to show you that this stuff evaporates off. You get dust coming off. That's what you're seeing here. This is mainly dust. This is mainly gas. And by trying to study those structures and understand what's happening and where the comet is relative to the sun, and then watching that as the comet goes around the sun, we can learn a lot about what happens to a comet. Comet Neowise had an interesting orbit. So in this little thing, you're seeing Mercury, Venus, Mars in their orbits around the sun, and here's the orbit of the comet. So here's Mars, Earth, Venus, Mercury. Notice, and these vertical lines are trying to indicate the distance below or above the plane that contains the disk that contains the normal planets. So it came, if here's the disk, it came from below the disk and then went up and over to the other side. So again, what's interesting was, unlike the planets, this comet um, was not in the plane that the other planets' orbits are in. It has an almost parabolic orbit. In other words, we're not really sure whether it ever comes back around, but if it does, we know that it takes thousands of, we're not sure what the orbit is, but we know it's at least thousands of years. We actually think it's non-periodic. But what's interesting is it has a diameter of about 5 kilometers. So imagine a 5 kilometer rock like Manhattan Island, a little bit smaller than that. That's the comet. It also has a rotational period that we were able to measure. It rotates once on an axis about every 7.6 hours. So another thing that we've been able to do in the last few decades is we can actually send spacecraft to have encounters with the comets. And so here are a couple of pictures. This was by the Epoxy mission. Here's a picture of a comet. You're not seeing the tail. You are seeing evaporation off the dirty snowball. And this was taken when this particular spacecraft came within 435 miles of the spacecraft itself. Here are a couple of others. This one we'll talk about in a minute. This is a photo of the Halley's comet taken by the European Space Agency mission Giotto. You can see again that it's got bright geyser-like jets, which we think are escaping water vapor, gas, and dust coming off one side of the comet. And this is the nucleus of another comet called Comet P. Wild 2. This was taken in 2004 by the Stardust spacecraft. So again, in the last couple of decades, we have actually sent spacecraft to try to take close-ups of comets. So one of the most important ones of those was the Rosetta mission. It went to this particular comet in called 67P for short. The mission was launched in 2004, and it arrived at the comet in 2014. It contained both an orbiter and a lander. And what this diagram on the right-hand side is showing you, and it will come back around and start at the beginning again. The blue shows you the Earth in its orbit. The red is Mars in its orbit. Then you see the planets. The green is the comet orbit. And so in order to get Rosetta, the spacecraft there, they had to send it out, and they used the other planets to give gravitational boosts to get the spacecraft to the right place. So it took off, it had an encounter with Mars, and that sort of slungshot it out so that it would reach up with the comet. It took pictures, and then the lander landed on the comet. Unfortunately, its batteries drained after a couple of days, but there was some restoration after that, and they got some pictures. And then they decided to crash the spacecraft into the comet to see what happened. So they got some pictures. Here's the picture of 67P. I showed you that picture before. You can see it's about 2.1 miles long. They claim that it looks kind of like a peanut shell, or they call it a rubber duck. So it's the rubber duck comet. It's a single object, but it has these two lobes. And here's actually a picture taken from the surface by the lander. It's very dark, it's hard, and it's dry, but it's rich in organic material like amino acids, glycine, and phosphorus. So we're actually being able to learn about comets by going there, which I think is pretty exciting. Okay, so how do we find comets over history? You look for objects that move with respect to the stars. Remember, the stars are relatively fixed in position on the sky. Solar system objects appear to move among the stars. And remember, the word planet actually comes from the Greek word for wanderer. So over the course of history, people have looked for objects that moved in the sky in different ways than the known wanderers. The known wanderers to the ancients, of course, were Mercury, Venus, Mars, Jupiter, and Saturn, which are the naked eye planets, the moon, and the sun. But once in a while, an object might appear in the sky, including something that was very bright and moved. So there are lots of carvings, paintings, tapestries that depict comets, like this one I chose. It's from the Book of Miracles from the 16th century, which depicts a very dramatic comet. The interpretation of comets over time has been good and bad. Basically, in many comets, in many cultures, if you saw a comet, that was a harbinger of doom. They appeared unexpectedly. People didn't understand what they were, so they were somehow disrupting the whole ordered movement of the heavens. This was probably bad. In some cases, they were actually used to say that they were signifying or related to bad things like plagues, famines, and war. Sometimes they were supposed to be a message from the gods, which was then interpreted in some way by the locals, but they came from the heavens, so the gods were responsible. And some ancient thinkers actually tried to understand them. So, for example, Aristotle thought they were somehow phenomenon in the Earth's atmosphere. But the ancient Greeks were into this idea, the Pythagoreans were into the idea that there were objects in orbit, were in actual orbits, and these things that were just were very far away and therefore had orbits that were years or decades or hundreds of years rather than the orbits of the planets. In fact, perhaps, although this is not certain, there are carvings on a pillar and an archaeological site in Turkey that is believed to go back to the 11th, 12th century BCE, called the Vulture Stone, which has carvings on it. Here's a reproduction. And it has a bunch of different drawings on it and markings. It's could be interpreted, it's believed by some people to represent a series of meteor falls, significant meteor falls on the Earth, what we would call an impact event related to what's called a comet swarm. Now, what I mean by that is sometimes, and maybe some of you remember this, in 1994, a comet called Shoemaker-Levy 9 came close to Jupiter. And as it came close to Jupiter, its nucleus was broken up by Jupiter's strong gravitational field, and different pieces of it fell into Jupiter one after another. That would be a comet swarm. If a comet came and the tidal forces of the Earth broke it up, you could have multiple impact events taking place. Anyway, one idea for the explanation of the carvings on the Vulture Stone is that this was related to an impact event. The comet swarm could have been associated with a period of global cooling which is believed to have occurred around 11,000 BC. Not proved, but a very interesting idea. So ancient comet sightings, the Chinese were the best and kept the best records, and they had comets going back to the 4th century BC. The Babylonians knew about comets. They understood that they followed predictable paths. And those date back to the last few centuries BCE. The ancient Greeks reported a large meteor that fell to Earth, and computer models that we have today suggest that might have been an appearance of Halley's comet in the sky. Not clear, but could be. First records and documented of Halley's comet go back to 240 BC from the Chinese. The Babylonians also recorded Halley's comets on texts that are located in the British Museum from 164 and 87 BCE. The Greek astronomers, as I mentioned, tried to explain the comets. Aristotle thought they were an atmospheric phenomenon. Brahe realized that if that were true, if they were nearby, you should be able to measure their parallax, that is, the apparent change in the position of the comet due to our motion. And he couldn't measure it, so he decided they must be very far away. So comets have been around and have been noticed in time. Here's Giotto's Adoration of the Magi with a comet up above. And comets were often seen, as I said, of omens or harbingers of disaster. And at sometimes in the Middle Ages in particular, which is where we start seeing these various depictions in artwork and whatnot, there was a great fear of the appearance of comets because they were associated with bad things like plagues and earthquakes. So perhaps one of the most famous of the artworks is the Bayeux tapestry from the 11th century, which shows Halley's comet because it appeared in right around the time of the Battle of Hastings, and it's believed to be depicting and portending the defeat of Harold II at the Battle of Hastings. So people have noticed comets for a long time because they occur relatively often. There are a lot more that we don't see with the naked eye. But even historically, you can see that there have been a lot of them. So let's talk a little bit about Halley and his comet. Halley observed a comet from his observatory on St. Helena Island in the middle of the South Atlantic Ocean in 1682. He was interested in comets, and he was at least playing the role of a scientist. So he went around and he found other people's reports of comet observations. Apparently, he knew about the laws of physics, he knew about Newton's laws of gravity and mechanics, and he understood Kepler's laws. He also understood that the giant planets, Jupiter and Saturn, were big, and if a comet went by them, the big planet, would pull on the comet and perhaps cause its orbit to deviate because of the gravity. And he used all this information to calculate the orbits. What I mean by that is the period of the orbit around the sun, the ellipticity, whether it was circular or really elongated, and the average distance from the sun, what we call the semi-major axis, of the 24 comets. And what he realized was that 3 of the comets that had appeared in 1531, 1607, and 1682, the orbital parameters that he calculated were all almost the same. And he decided that this was actually a single periodic comet which would reappear again in 1758. And that is why Halley's comet is called Halley's comet. Unfortunately for him, he died in 1742. He predicted it would, he observed it in 1682. He predicted it would come back in 1758, but he didn't live that long. So here's Halley's Comet. We believe it orbits for 76 years. People have modeled its orbit by observing small deviations, knowing where the planets are, doing a big calculation. And that we believed it's been orbiting the solar system for at least 200,000 years, maybe 200 million years, but we don't exactly know. The last passage was in 1986, and the next passage is in 2061. And if we're all around, then I will buy you a drink. The first confirmed record, as I said, was the Chinese in 240, and it's named after Edmund Halley. It probably used to have a longer orbital period, but by coming in close to the sun, it kind of got captured and was redirected by Jupiter and Saturn. The nucleus is relatively small. It's 15 kilometers by 8 kilometers, or so 9 miles by 5 miles, but it's and about 5 miles thick. Its tail, when it comes close to the sun, can extend more than 100 million miles. Okay, so it was the European Space Agency sent up a satellite called Giotto, which again used the orbits of the planets to get it out to Halley's Comet. It was launched in 1985. It came close to the Earth, the comet, so the spacecraft actually succeeded in getting within 600 kilometers. There were some various problems with the mission. It was hit by a solar flare. There were software command issues. There was an update that didn't work. It was hit by small particles, but it managed to stay on track. At the same time, the Soviets had launched a couple of satellites because they also wanted to take pictures of it. So we can see here two different pictures. This one taken by the Russian Vega 2 image. And here's the one from the Giotto image taken from closer up. And again, you can see that it is double lobed, but a single structure. And here you can see the jets that are coming off where the gas is being evaporated. So the bottom line is the dirty snowball analogy is a good one. About 80% of the gas is water vapor. There's lots and lots of dust. The dust particles appear to be organic, which means they contain a lot of carbon, rather than being stony, which means that they would contain more stuff like iron or silicate, stuff like that. The nucleus is an irregular shape, like an unshelled peanut. What's curious about this is it does not reflect much light, which also tells you something about the material that must be in it. It reflects only about 4% of the sunlight that hits it. But there are on the sunlit side, there's clear evidence of jets of gas and dust that are erupting from this rocky, icy, dirty snowball surface, which is inhomogeneous and has bits of dust and different gases. As the sunlight comes in, a piece will kind of get ripped off and light up, and you get what looks like a jet. So what have comets taught us? Again, we think that they come from the early solar system. They're bringing material in. By studying their orbits are really very different from the orbits of the planet. And that teaches us that the early solar system was a chaotic place with little bits of things smashing into each other. The giant planets were out there and they would scatter material. The solar system hadn't completely formed its ninth planet. It was a really messy place. And so comet orbits were probably the comets started out far away, but interactions with the outer planets caused them to come more into the solar system. As David was asking, some comets have probably been disrupted and completely obliterated when they came past the sun. Other ones go, like Halley's Comet, keep going around and around and around, and we think it's done what it's doing now for 200,000 years at least. David, another question.
Is it possible for a comet to accumulate additional material as it travels through the solar system?
It's possible it could accumulate other material, but it doesn't accumulate a lot of other material, we don't think, because if it got too big, if it ran into something else that was a lot bigger, it would get destroyed. Another thing, which is kind of an aside, which someday we might talk about, is what this tells us is that the orbits of the planets today are not necessarily the same as the orbits of the planets in the past. The planets actually, over billions of years, have interacted with each other. And we think, in fact, their orbits migrate. I'm not going to go into that, another topic for another day. Okay, studying the long period comets, as I said, can tell us what the early solar nebula was like. And what we find out is that comets are made of very primitive materials. But what's interesting is that a lot of the dust, the gas, and the frozen volatiles that are seen in comets contain the stuff that are essential for the development of life. How life developed is still a completely open question, but it's very interesting that the stuff out of which we are made of in life here on Earth existed in the early solar system. And in fact, it is hypothesized that some comets from the Oort cloud may have delivered substantial amounts of those complex organic molecules to the young Earth. But I just want to finish up in the last couple of minutes talking about something that's even more bizarre. And that is that not only are the comets that we identify in the solar system, we now know of 3 comets which don't come from the solar system. They're in the solar system right now, but they actually come from outside the solar system. And the first one of those, which is called Oumuamua, was discovered in 2017. Here's a photograph of it. It is elongated, it has a rocky shape, it has no tail, it has no coma or dust, but it shows an unusual acceleration as if it's being jetted. So in fact, people were suspicious that maybe it wasn't a comet. The second one is called Borisov, and here's an image of it. It's roughly 1 kilometer long, but it does have a coma of dust and ice, but it has very low levels of carbon dioxide gas, much lower than we would expect in the solar system. And here again, just to remind you that these comets travel on extremely weird orbits. And so here are the orbits of the planets, and you've got Comet Borisov and Comet Oumuamua coming in the other direction, and I hope my brother's dog is not disturbing you too much, but he's a very nice dog. So why do we think these comets are interstellar? And it's because they're strange. They're strange in that they're traveling in their orbits much faster than we would expect if the comet was in orbit around the sun and gravitationally bound to the sun. They often follow hyperbolic trajectories, which suggests that they're passing the sun only once and are never going to come back. They also have weird chemical makeup that's just unlike most of what we see elsewhere in the solar system. In particular, Borisov has a high ratio of carbon monoxide to water, and the last comet, which I'm going to talk about, which is the one most recently discovered, has a really unusual signature, which it has really high concentrations of nickel and iron, which are completely unlike typical comets in the solar system. So it is true that this last comet does also appear to be extremely old. And in fact, based on our models, which are somewhat uncertain, it appears to be older than the solar system. So there's something really weird about these things. So that's the comet which recently in the news, CNN and elsewhere, has discussed to being possibly alien technology. Uh, it was discovered in 2025 by a telescope, which is part of the NASA Planetary Defense System, which is looking for comets and asteroids that might be coming and potentially could hit Earth. It's very hard to observe from Earth because it turns out, as it's passing through the solar system for its one and only time, it's opposite the sun from the Earth, actually near Mars. It has an unbound hyperbolic trajectory that appears to be coming from outside the solar system, and its orbit is going in the wrong direction. Okay, it's retrograde. We don't know the size very well, but it has the size of a comet. It also has a coma that is the size of a coma. So it is doing comety things. It looks like a comet. And it has a maximum orbital speed, and you can't, and you see it reached its closest point to the sun on October 29th. It cannot be explained if it orbits the sun. It must come from outside the solar system, which means it's interstellar. So what's really cool, there was a webinar that NASA put on a week ago in which they announced that since it's really far away from the Earth on the other side of the sun, near Mars, it's really hard to observe from the ground. But because it seemed to be so intriguing, NASA deliberately decided in October, at the end of September, I guess, in September, to take every spacecraft that could possibly observe this comet and observe it. And I think that kind of strategic thinking is pretty amazing. And so I'm just going to flash these. These are two sets of images that you can find in the NASA Atlas image archive, which were taken with all sorts of different spacecraft. The Lucy spacecraft, which is on its voyage to the Trojan asteroids. Here are from the Mars Perseverance rover. Here's from the satellite that observes the sun all the time. They've used everything they could, the James Webb Space Telescope, the Hubble Space Telescope, and they're trying to combine all this information together because this is such an unusual object. Let's use the telescopes that we have because this is such an intriguing object. So it is very intriguing. Curiously, although what we see is, we normally say that the tail is always pointing away from the sun. This one actually has a sunward appearing tail or an anti-tail. And it's believed that that has to do with the size of the dust grains and the kinds of gases that are in it that have actually created a jet that's coming out directly pointing towards the sun. And these have been observed in other comets, but they're very rare. But again, it tells you something about the size of the dust particles and the composition of the gas. It has multiple jets, and so they're trying to see if the jets arrive from there being an explosion on the comet or just that it has multiple lobes that are being affected differently. It has, as I mentioned before, it has a really weird chemical composition that is unlike what we see in the solar system. We also think that the grain size is larger than we would expect. And so as it passes through the sun and goes by, which is happening right now, there are lots of observations being taken which have not been analyzed yet. But watch out, this comet is going to be, to use a bad pun, a Rosetta Stone for studying interstellar comets. But it has been claimed that this is alien technology. So if you see any articles like this one, scientist predicts alien arrival, and will tell you everything about the hostile mothership that is hurtling towards Earth, My suggestion is don't waste the 3 minutes. It's not extraterrestrial technology. In fact, if you observe it, this is an early image from the Punch spacecraft. It's not a great image, but even in this early image, you could see that this was forming a tail. It does cometary things. It's cometary in uh, its orbit, its structure, its tail, its jets, everything like that is what a comet does. So we are reminded by Carl Sagan's statement in Broca's brain, which can also be attributed to David Hume and Pierre-Simon Laplace. Extraordinary claims demand extraordinary evidence, and the extraordinary evidence for this being alien technology does not exist. So again, we learn what comets have taught us is they tell us about the early solar system. They tell us about that it was very chaotic and there were lots of collisions and things broke up and planets moved around in their orbits. It tells us about the composition, the organic molecules that were necessary for the development of life on Earth were present in the solar system in those days. That was already there 4.5 billion years ago. Interstellar comets are really interesting because they can even tell us whether the solar system is like other systems outside. And we think they can tell us about the conditions and the processes that occurred billions of years ago. So anyway, that's a little bit about comets. And I don't know about you, but I learned a lot about comets in making up this talk. So I thank you for that. So we have some questions. Great. Okay, Elena and then Ed.
I just had a comment. Back in 2017 or so, I was on the Caesar team, which was
Right, right.
mission led by Squires at Cornell to actually bring a sample back from Churyumov Gerasimenko, the peanut
Right, P67. Yeah.
P67. It didn't get selected, but a lot of, several years of work went into planning the mission. And the idea was that a sample would be brought back and it would come screaming into the atmosphere in 2038, get picked up in Utah, taken to Texas, and analyzed to see what components that maybe could tell a story about life in the solar system. The mission that actually got selected was Dragonfly, which is
Right.
go to Titan. It's a little helicopter and study things around the methane lakes. But
Yeah,
yeah,
one of the lessons of this is these missions are amazing. They're very expensive and they take a huge amount of time to get developed and get there.
yeah.
Caesar's not completely dead. Someone will probably do this someday. Ed,
If there's no atmosphere out there, what's pulling these particles off of these comets? Is
it's
it
it's like
purely
it's
heat?
like it's like you're shining a laser on them, or you're shining you're heating them up. The sun
Okay, it's
is
heat.
heating them up. The sun is heating them up, and the fact is they're like dirty snowballs. So, you shine you put a flame against a dirty snowball and there's a little more rocky stuff over here. It's surrounded by ice, but the rock heats up and it breaks off and you get a jet. Or all of a sudden it gets enough sunlight that some of the molecules burn off.
Okay.
David?
Yeah. So when you were talking about this last comet, the interstellar comet, one of your points on your slide said that I think it was that the jets could come from evaporation or whatever, or by an explosion.
Yeah, well, what we merely mean by an explosion is that suddenly there's a concentration of light in a particular location that causes not just a drizzle of material off, but a big amount of material off. A
Okay.
piece breaks off.
So it's
So
not some internal
it's not like thermonuclear fusion or a bomb or something like that.
or a volcano or
It
something.
just It just means that something happens on a short time scale. Whereas a jet you might think of as something that's happening over a short period of over a period of time. Yeah, Alan.
So if we think about a typical long period comet, one of these coming from the Oort cloud and highly elliptical orbit, as you said, to the inner solar system, do we have an idea, again, on average, was that maybe launched by just one near encounter with another star, or do we kind of expect it's a long sequence of
It's
things?
the thing is the thing that they learn is that the early solar system in the early solar system there was the sun forming at the center, but there was also this protoplanetary disk, which was also embedded in a cloud that had broken off. And in those early days, there was little bits of stuff that was denser than other little bits of stuff, and it was very chaotic, and things got deviated by gravity all over the place. The planets probably migrated in their orbits. Some of them might have migrated out, some of might have migrated in. Not all of the planets are the same size. So if you come close to Jupiter, you are deflected more than if you come close at the same distance close to the Earth. But it was very chaotic. There was lots of stuff happening. It was like this big protoplanetary disk and cloud was full of little bits of stuff. Gravity has a tendency to cause stuff to aggregate and grow bigger. That's what gravity does. It makes things bigger. But there was also little bits of stuff all over the place, and it was chaotic. And that's basically what comets have taught us. Do people understand it all perfectly? No, but they're able to do these big simulations where they try to track Halley's comet, for example, and they can keep Halley's comet in its orbit roughly for 200,000 years without having it be too disturbed by Jupiter and Saturn. But anyway, this, the bottom line in astronomy is we don't understand it all, and that's what keeps astronomers employed. So anyway, that's my story about comets. I thought it was interesting, and I hope you did too.
Thank you.
So,
Thank you,
so we're
Mark.
not meeting in December, but we'll probably meet in January, and I don't know what I'll talk about then. I know I owe David something on dark energy, but that's too hard for me. But I'm trying to I'm going to try to put together eventually something on dark energy for David. If others of you have other things that are interesting that you'd like to talk about. And Elena, if you'd ever like to tell us about your experiences, I think that would be a really interesting thing. Would you like to tell us about what missions you worked on and what you did?
Sure, I think I did a couple years ago, but I can.
Yeah, but not at our age, none of us remember anything from a couple of years ago.
Well, my memory's starting to fade too.
Yeah, no, I think it would be really interesting if you would like to do something. I would be delighted to hear your story. I mean, I know some of it, but not at the depth of water that you could tell us about.
It started out with the asteroid arrows, so
Right, right.
going way back.
Okay. Anyway, have a great holiday, everybody,
Thanks, you
and
too.
we'll see you around.
Martha.
Bye-bye.
Thank you so much.